Hello! In this video, we're going to prove the following theorem. Suppose A, B, and C are sets. Then A set minus C is a subset of the union of A set minus B and B set minus C. Now really, we're trying to prove that every element in this set belongs to this set. So to prove that, let's give ourselves an arbitrary element of A set minus C. I'll call it X. The whole goal now is to show that X must also belong to this set. So to start out, since X is an element of A set minus C, by definition, this means that X is an element of A and X is not an element of C. Now, to show that X is an element of this set, we're going to split this up into two cases. Either X is an element of B or X is not an element of B. In either case, we're going to show that X is an element of this set. Let's start with a case where X is an element of B. Well then, we see that X is an element of B and X is not an element of C. So these two facts tell us that X must be an element of B set minus C. So, since X is an element of B set minus C, X must then be an element of the union of A set minus B and B set minus C. And that is what we wanted to show. So this completes the case where X is an element of B. Now let's move on to the case where X is not an element of B. Well, in this case, we see that X is an element of A and X is not an element of B. And these two facts tell us that we must have that X is an element of A set minus B. So, since X is an element of A set minus B, we must have that X is an element of the union of A set minus B and B set minus C. And that is exactly what we wanted to show. So we see in either case, X is an element of the union of A set minus B and B set minus C. Therefore, X must be an element of the union of A set minus B and B set minus C. Now putting this together, we see that under the assumption X is an element of A set minus C, it follows that X is an element of the union of A set minus B and B set minus C. Since X was arbitrary, this means we have shown every element of A set minus C belongs to the set A set minus B union B set minus C. So we've shown that this is true. So this completes the proof. And so yeah, that's pretty much it for this video.